So as for the second part, the normal to the curve at the point where theta is equal to alpha meet x-axis at point A, show that the x-coordinate of A is k alpha, where k is a constant to be found. Okay, great. I'm not sure how this is going to look like, but usually what I'll tell my students to do is just sketch using the GC for the parametric curve and just roughly understand what's going on. You may not need it, but no harm sketching it out. So I'm just going to go to math. Just want to change it to, okay, this is already in parametric. So I'm just going to clear this out. So this is 2 theta minus sine 2 theta. Okay. And this is 2 sine theta square. Now take note the window value. Your T-mean would be 0 to pi, right? So when you sketch this out with 0 to pi here, just put it pi and just graph it. Maybe zoom standard a bit. All right. So it looks like it goes to the other side. Sorry, this is pi. Sorry, when you put zoom standard, it will go. Yeah, so this is one-sided here. So I'm going to zoom fit maybe. Maybe I'll just change the window setting here. X min I put -1. X max I put 6. Probably will help. Oh, no, doesn't help. So I'll just put, let's say 8. And my Y min I could just put -1. And my Y max I could just put 5, I guess. Yeah, maybe put 3. Graph it. There you go. Now this is the graph here. So you are told to show, okay, I'm just gonna put this, take this graph out. So this part here for second part, what we need is actually the theta, where theta is alpha meets x-axis at point A. So I'm not sure the normal. So I'm just gonna randomly take one point, which is this point here, and this is where theta equals to alpha, right? So when you draw the normal out, it says that this point here is this is A. Okay, so you're told to show that the x coordinate of A is k alpha. Okay, that's pretty okay. So great. So let A be A comma 0. Okay, so we need to show that A is actually k alpha. That's the whole point there. All right. So let's see. So when theta equals to alpha, we know that dy dx is actually cot. So, or rather, m tangent is equals to dy dx when theta is equals to alpha, which is actually cot alpha. Okay. So this gradient here is cot alpha. So m normal multiply with m tangent is equals to -1. So in other words, gradient of normal will just be -1 over m tangent, which is actually -1 over m normal. Normal would be m tangent will be cot. So it just be negative tangent alpha. Alright. The point here, so when theta equals alpha, obviously we're just gonna have the point is 2 alpha sine 2 alpha. So this point here is actually 2 alpha minus sine 2 alpha, comma 2 sine square alpha. Great. Okay, so that's about it. That's the point at the normal. So gradient of normal would be y1 minus y2, x1 minus x2. So I'm just gonna put like 2 sine square alpha over 2 alpha sine 2 alpha minus a. And I want to find a. Okay, a is what I want to find. Or this is -0 equals to negative tangent alpha. Oh, it looks like a handful, right? But this just chill and tangent alpha 2 alpha minus sine 2 alpha minus a. So I just cross multiply this up, and sine would just be 2 sine square alpha minus sine alpha cosine alpha. You could just skip step when I'm trying not to skip too many steps so that you all could follow. So this part here will be alpha here. So this will be 1. And this multiply up, there will be cosine 2 sine alpha negative cosine alpha is equals to 2 alpha minus sine 2 alpha minus a. Great. So it looks promising because this is actually this, right? So this is actually 2 sine 2 alpha equals to 2 alpha minus sine 2 alpha minus a. So a equals to 2 alpha. Okay. Yeah. So xa, hence x coordinate of a is 2 alpha. K equals to 2. That's how I do this question here proficiently.